I think that was
Yeah, this one.
but
I know.
don't. You can try. I don't have to. I saw that.
I think he's good. I don't know. I hope he's going to make worse than this. He's definitely going to be on it.
No one's in school.
Yeah, but this is different.
Why are you hating this?
Emma, did you still
Eyeball.
erase? It's Aiden. Erase.
Every single one of my
Mary.
or high.
How'd you get? I have it. How did you get 5 out of 5?
Wait, you mean?
Whatever I'm not. Okay, so we'll play 5 times 100. Stop. 500 and 5 times 25.
Hey, whoever did that one time for you on that one. Yeah.
Alright, check yours with these. I should have all eyes and ears up this way. These are numbered incorrectly, but this should be 8, this should be 125, this should be 1, this should be 16, this should be 625, and this should be 32.
Why they all numbered?
I don't know. I have never changed them. I keep meaning to, and every time I think about it, I forget. What do we think this unit is on?
Exponents.
Exponents.
Oh, yeah. I forgot.
So I want you to look at your schedule because I need you to fix a couple things. Because I forgot that next Tuesday, so the 3rd, we don't have, you guys don't have school. So all the dates are kind of messed up.
Just on Tuesday we don't have school.
Just Tuesday.
So
We
we
don't have
come in
school.
Monday.
It's election day, and they're using a lot of the buildings. So no one has school. So where it says Monday, Tuesday, 3, 2, 3, 3, change that to Monday, Wednesday, 3, 2, 3, 4. Stop talking. Thank you. The next one should be Thursday, Friday, 3, 5, 3, 6. And the last one is Monday, Tuesday, 3, 9, 3, 10. So our test is in 2 weeks. Starting from where?
So next Tuesday. Next Tuesday we don't have
Monday,
school.
Tuesday should be Monday, Wednesday, 3, 2, 3, 4. And then the days follow from there.
So next Tuesday. What is that?
Next
So
Tuesday is
we have the rest of this week.
Okay. Tuesday.
literally next.
I'm really slow. Sorry.
I should still have all eyes and ears up here. As we move forward, so after we finish this, we have a unit on radicals, a unit on factoring, and a unit on quadratics. The radicals is a really short unit. We have I'm not even going to call it a unit because we're going to do it during SOL review. Inverse and direct variation. But we really only have 3 units after this. So we're almost done.
Woo!
After this unit, we are going to be reviewing a lot more, taking class time to review SOL stuff a lot more. Think of your Shark Bites as mini SOL reviews that we've been doing over time, but now it's actually going to be SOL reviews. I need you to keep this date in mind, because right now it seems far, but it will be here sooner than we think. May 19th is our SOL. So once we get to April, it'll be here really, really fast.
Yeah, that's my birthday.
If you've looked at Khan Academy, you do have 4 Khan Academy quizzes for this unit that will be due at the end of this unit, and that will be next Friday. Do we have any scheduled questions?
What day was the last day?
11 to 12.
The last couple weeks is final exams,
So we don't come to school
that,
on those days?
that depends on if you have to take one or not. The last thing I want to say about the stuff you have a little blue book. Everyone look at that little blue book. That is yours for extra practice. So after we've done everything we do in class, you can go through that and practice at your own, on your own, whenever. You can come ask me questions about those. We can work through those together before or after school. But that is for you to have extra practice.
Is something more than you trying to do?
No. But if you feel like you got whatever we're doing in the notes, I would advise you to go practice in the blue book. Find your notes that look like this.
I don't know what else.
Alright, so before we get into some of our exponent rules, I want to talk about these. Also, we need to understand what these words mean. I'm going to go back to the warm-up for a second. Does anyone know what this number is called?
Coefficient.
No, it's not coefficient.
I tried.
The base.
It's the base.
Oh my god.
So on your actual notes, I want you to write one of those examples. Write one of those examples and say that this is your base. Is the exponent or is the power? We may change those words, the power of, the exponent, or we may actually just say the number. So now that we know the difference between those two, this is saying when we have a negative base raised to an even power. So give me a negative number.
-4.
I heard -4. And let's just use 2 as an even power. What would this be?
No, 16.
It'd be
It
16.
wouldn't be negative because this is the same as -4 times -4. Oh, so it's positive. So anytime we have a negative base with an even power, this will be positive if we use parentheses. Oh, that's cool. If we don't use parentheses, here's what happens. When we don't use parentheses, or if you put -4 squared in your calculator, you would get -16 because your calculator is doing this. -1 times 4 times 4, which is not the same thing.
Would it be wrong?
It would be wrong, yes. So use parentheses. Now let's look at this one. Negative bases, we can use -4 again. But now we're going to raise it to an odd power. Let's use 3. And I'm going to expand this out, just like we did there for the square. What would this be?
Would be negative.
It would be -64. Because this would be 16, and that would give us -64.
So whenever it's an odd number, it's negative.
Whenever the power is odd and the base is negative, you will end up with a negative. If we didn't use parentheses, and I just put -4 to the third in my calculator, or in you guys' calculator, it would do this same thing. I have -1 times 4 times 4 times 4. But you would still get the same thing. You would still get a negative. So with even powers and negative bases, the parentheses don't really matter. I'm sorry, I said that wrong. With odd powers and negative bases, the parentheses don't matter. But with even powers and negative bases, the parentheses absolutely matter. Use parentheses anyway, and then you won't have any issues. Right? Now we're going to talk about when we have negative exponents. So our base is not negative, but our exponent is now negative. Before we do that, let's talk about base. How would I write out 0 squared?
0 times 0.
0 times 0, which is
0.
How would I write out 1 squared?
1 times 1.
Which is 1. 2 squared,
2 times 2.
which is 4. And 3 squared.
3 times
3, 9. When we have negative exponents, something weird happens. So let's call it math magic. When we have a negative exponent, what happens is I take this base. Remember that each whole number is really over 1.
I don't like this.
Okay. So without us doing that, all whole numbers are over 1 because it will still be the same. You're going to take this base and you're going to flip it. This is where the math magic happens. And then your negative exponent becomes positive and it moves to your denominator. We are going to go back to the calculator.
What scenario would you be using this? Why do I have to?
But I just wanted you to do it without the calculator because we're going to be doing this for a second. But why? So now we actually haven't found the answer. So we know 0 to the power of 2 is 0, right? But what's any number over there?
0.
1.
What a number is. It's undefined. Oh, that's so cool.
I don't.
So 0 has this very special case. You can't raise 0 to negative exponents because you get undefined.
So whenever there's a 0 to a negative exponent, it's
It's undefined always. 4 zeros only. Let's do the same thing with 1. If I flip this, this would be 1 over 1. You can simplify it, but I'm just going to write it as is for right now. I'm going to take the exponent and make it positive in the denominator. Now, we know 1 squared is 1. 1 over 1 is 1. So I can say that 1 to any positive power will be 1, and 1 to any negative power will still be 1. It does not matter. 1 is also a special case. But let's do 2. If I flip this, what would this be? 1 over 2. My exponent is still positive in my denominator. I know 2 squared is 4. So 2 to the negative 2 is 1/4. Which would also be 25. So anytime you have a negative exponent, what you could also do is take the final product and switch it. It's something gone over there.
Hi!
Where did you get the cool music?
Oh,
I'm so sorry. It's okay. Alright, Eisenhu's back up here. So you could do your negative exponents one of 2 ways. You could take the base, flip it, move your exponent to the bottom, and do that. Or, if you know what 2 squared is, you could take that number and flip that. Both would work. So what would 3 to the negative 2 be? 1 over 9.
Negative.
Not negative,
Oh, sorry, one.
just 1
9.
over 9. Now, you could do this in your calculator, but you will get decimals. So negative exponents in your calculator is complex to do in your calculator unless you know what that fraction is. In a minute. You could make it a fraction.
So you could just do, you can like do 3 times 3 is 9. So it would be like 9
Yeah, so I could say that this is the same as 9 to the negative 1. I do want to say one other thing. All of your numbers by themselves have a variable of 1. You don't ever see it. I could put a exponent of 1 for all of the numbers on this number line. It's there, we just don't see it. So any number by itself has that. So when you flip things, if I have 9 and I want to raise it to the negative first power, I'm going to flip it and raise it to the first power. And it would be the same thing. So I could say this is 1 over 9 to the first. We're going to do this part when we get back from lunch. So you can go right there.
it's like, it would make Starburst so juicy.
Alright, Eisenhu's back up here. Alright, now we're going to talk about these variables and how to do those. Now, we don't know what A is, what number A stands for. It's just going to be some variable. But I could expand this the same way we were doing the numbers. A times A.
Yeah.
Goes off. What would A times A give us?
A.
Two.
I said A already. A was the coefficient.
A2?
A squared.
Ha, got it.
Wow, that was so advanced.
So don't really know what A is, but if we did, then we could actually write it out. I could keep doing that. This would be x times x times x, which would give us
X3.
x cubed.
What?
I mean, I don't know these terms, right? It's X3 or X2.
Or x to the third power, not x3. How would I write d to the first power? D
D1.
just d. The 1 is not necessary. I could expand this to say y times y times y times y times y. And that would be not b. What would that be? Y to the 5th power. Now, just like with all of our numbers, all of our variables also have a imaginary 1 underneath. So if we have a negative exponent, we are still flipping the base to its reciprocal and making the exponent positive. So if I do that for this one, it'd be 1 over a to the 2nd power or squared. So get out of the habit of saying whatever 2, whatever 3 to the power of squared cubed. We need to start using that vocab. There's nothing else we can do here, so that would just be that answer. So what would this be? 1 over x to the power. 1 over x to the power of 3 or 1 over x cubed? Yeah. What about d to the negative 1? This would just be 1 over d. Putting the 1 again is not necessary. What about y to the negative 5th? 1 over y to the power of 5. 1 over y to the power of 5. Okay? Either somewhere in some empty space on your notes or on the back of your warm-up, I want you to write these 6 problems.
Simple.
Oh, those are write them so you have space to work. Writing them on the back of your warm-up is probably better. We're going to do 2 of these together, and then I'm going to let you try the other 4.
Can we do 3 and 5?
We're going to do this one and this one.
No. What about 3 and 5?
Alright. So let's start off with this one. If we have 5b, all of that is squared. I could rewrite that so that it's 5b times 5b, right? Isn't that what 5b squared means? Yes. Now, because multiplication is commutative, we can change the order, it doesn't matter. I could rearrange this, so let's say I drop my parentheses, and I just have 5b times 5b. I could move things around. Maybe I want my 5's together and my b's together. It would still be the same thing. 5 times 5 equals, 25. What would b times b?
B2. B to the power 2. B squared.
Power of 2 or b squared, yes? So when you are multiplying these out, you can separate them like this. Another way you can look at it is taking this exponent and giving it to both of the bases. So rewriting it as 5 squared b squared. Wouldn't that be the same thing?
Yeah.
So you could do either way. Don't overthink this. Now let's do this one. Before we do anything, we have a negative exponent. So if this entire thing is my base, I could flip it. This whole thing is over 1. I could say that this is really 1 over 3a squared. And then I could do one of two things. I could either separate this just as we did up here. So I know this is the same thing as 3a times 3a. I could rearrange that so that my 3's are together, my a's are together. What would this be?
1 over 9.
9 to the power, or 9a to the power of 2.
That is too confusing.
Or 9a squared. But remember I said there was another way to do this. So you could have also taken this 2 and made it the exponent of both to give you 1 over 3 squared a squared, and you'd get the same thing.
That's confusing.
So right now, I just want you to take this step by step. Do this step by step. And I want you to go ahead and try those 4. You're going to work on this at your seat. And then we'll come back and we'll talk about them. If you have questions, please ask.
What are you worried?
So I'm going to do each one both ways, the separating and the applying the exponents. I think in this one we can't really do the separating one, but for the negative 1, I could take this base and change this. This entire thing is being raised to the first power, so my parentheses just drop. But if you were using the method of taking this exponent and making it the exponent of each base, that would be 3 to the negative 1, a to the negative 1. I would do the negative exponents for both. So this would become 1 over 3 and 1 over a. But your final answer needs to be 1 fraction. So you would combine those two
What's up?
by multiplying.
I knew you were gonna say that.
So you could do either one. So we should not be talking. Alright, let's do the next one. I'm going to do the separating method first. But we need to listen. In order to use the separating method, you have to use the negative exponent part first. Make this AB to the 3rd power.
Bro, I'm taking all this hair off.
Danny, hurry, you stop talking. Separate each of your ABs.
Not sweet at all.
And then you could rearrange it, rewrite it. I could put all of my A's together and all of my B's together. times a is the same thing as a to the power of 3. And b times b times b, b to the power of 3, b to the power of 3. If you are using the method of taking the exponent and making that the exponent of both, I would have a to the negative 3 times b to the negative 3. I would then change both of them. This would become 1 over a to the third. This would become 1 over b to the third. But we still need to combine them. And when we combine them, we would get that final answer. So I'm not saying do both of these methods. I'm saying choose which one you like better and do that. Now I'm going to do the method where you take the exponent and apply them first. Because that would make this a squared b squared. And that is the answer for that one. But if you use the separating method, you should get the same thing. AB squared is the same thing as AB times AB. We could rearrange it so that this is A times B times B. A times A is A squared, B times B is B squared. And then for this last one, again, we can do both methods. I'm going to take this and make it the negative, or do the negative exponent first. And then I could separate them. 2x to the second power is the same thing as 1 over 2x times 2x. I could put all the 2's together, all the x's together. And then get 1 over 4x squared. But you could also take the exponent, apply it to both, so that you have 2 to the negative 2, x to the negative 2. You could take the negative exponent of both, 1 over 2 squared times 1 over x squared. 2 squared is 4, so this becomes 1 over 4 times 1 over x squared. We would still need to combine them though. And when we combine them, we would still get 1 over 4x squared. Do we have any questions on any of those? Okay, on the back, there's a section that you're missing. Go ahead and fill in that column. Zero to the power of x, yes. Alright, so let's look at this table. You should see some sort of pattern that's happening. As you go down in exponents, what's happening? It's dividing by 2. It's dividing by 2 each time. So when we get to 2 to the 0 power, we get 1. Same thing with our 10 to the x. We're dividing by 10 each time. So when we get down to 10 to the 0, we get 1. Can you think of what happens when we have anything to the 0 power? What rules? What's the rule? Are these undefined?
It's 0.
1. Now, this almost always works for 0. But I want to keep continuing this pattern for a second. Even when we have a negative base, if we keep dividing by that negative base, the same thing happens. So whether our base is positive or negative, if we put 0 in as the exponent, we still get 1. We know that 0 to any positive exponent is 0. Before we talk about what, bless you, 0 to the 0 power is, let's go back to our negatives. What's 2 to the negative 1?
2 to the negative
1 over 2. So the pattern is still following, Ivan. We're still dividing by 2. 2 to the negative 2.
I know. 1 over 2. Is it 2 squared?
1 over 2 squared, which is
1 over 4.
1 over 4. So that pattern is still following. I don't need to do 2 to the negative 3 because it would keep going. If I did 10 to the negative 1, what would that be?
1 over, wait, 1 over, no? 1 over 10?
It would be 1 over 10. I'm still just dividing by 10. What if I did 10 to the negative 2?
1 over 10.
1 over 100.
Oh, it's 100.
Because it's 1 over 10 squared.
Oh, that's 6 squared.
If we were doing the negative 3, negative 3 to the negative 1. It will be 1 over 3, but it would be negative 3 because we have an odd power. What if I did negative 3 to the negative 2? It would be 1 over
Negative 1 over 9.
Would it still be negative?
No, it'd be 1 over 9.
It'd be 1 over 9 because you have a negative base with a positive or with an even power.
Oh, so if it's odd.
If it's odd, it would be negative.
So that's when there's 2 cancels out.
Yeah.
So when there's 2 cancels out, but there's a third one or how many?
When there's even, the negatives cancel out. Now, we were just talking about how 0 is a special case when we have negative exponents. What's 0 to the negative 1?
Undefined.
Undefined.
Oh,
What about 0 to the negative 2?
undefined.
It's still undefined. So, when we look at this, if all of these numbers, if we put 0 in, we get 1. But we can't really divide by 0 because we keep getting undefined. It can't be 1 and 0. So 0 to the 0 power is undefined. So 0 is a special case for 0 exponents. You could put that in your calculator. 0, caret, 0, and you'll get error. 0. Man, 0 is so depressing. So, For your negative exponents, you have a specific rule you need to apply. Take the base, change it, make the exponent positive. For 0 exponents, the answer is 1 unless it's 0, unless your base is 0. Do we have any questions on 0 and negative exponents?
Nope.
I don't think so.
So for the rest of class, listen. For the rest of class, you have a practice you are going to work on. If you don't finish it, it is homework. But you should have time to finish it. As you're working on this, notice that there are not parentheses. So be careful with your exponents.
If you don't finish it, he said no.
Yeah, you get
Every time you're in third grade,
I know that
You guys should be using
we probably like this. Oh yeah, Gary, Gary,
die soccer.
Hey Gary. Hey Gary.
Run.
Oh no.